Hello everyone, welcome to my chemistry channel BL Das, Short and Sweet in Chemistry. Now I am going to explain the topic, that is conformation of hydrocarbon, alkane related, and especially it is ethane. This is part 2 where I am going to explain conformation of ethane, and in ethane what happens? Ethane, that molecule is CH3, single bond CH3. That means here this is one single bond. Already I have explained in part 1. This is sp3 a hybrid orbital of carbon, and here overlapping with this carbon, and these two carbon atoms are bonded by a single covalent bond, and that is sp3 overlapping. Each carbon atom is linked to 3 hydrogen atoms. One carbon is linked to 3 hydrogen. That means here suppose C, this is 1 and this is 1 and other one is this is 1. That means 3 hydrogen atoms attached to 1 carbon. Similarly, the second carbon also attached to 3 hydrogen atoms. So what happened here? This is the molecular formula, molecular formula of ethane. C2H6 is the molecular formula, and CH3 that is structural formula. And now if you want to expand the structure, then you can observe here this carbon, let us this is one carbon, this carbon is 1 and this carbon is 2. Then what happened? In 1, 3 hydrogen atoms are attached, and 2 also carbon, the 3 hydrogen atom attached. So if one of the carbon atoms methyl, now you can say 3 hydrogen, what is that? Methyl group. CH3, methyl group. So is kept fixed. Suppose I want to fix this carbon 1 and having 3 hydrogen atom, and other is rotated. Now if you want to fix the carbon 1 and 3 hydrogen, and this carbon 2 is rotated, and about what axis? This is the axis C. This is one single bond, so put like this, and here this bond is rotated. Then what happened here? If the bond is rotated, then what happened? Then a infinite number of arrangement of hydrogen atoms attached to this carbon takes place. So what happens here? If you want to fix this one you want to fix, and this can rotate until an infinite number of structure is formed in space. That is called spatial arrangement. So hydrogen atoms of the second carbon atoms are possible. Similarly, if you want to fix this one, here also it can rotate a large number, infinite number of structures are possible. And what happened then? Now see how the rotation takes place. This infinite number of different arrangement called. So since you fix this carbon 1 or carbon 2, other part is rotated. One carbon if you fix, other carbon rotating all the hydrogen atoms automatically, and then form a large number, infinite number, and that is called conformation of ethane. Infinite number of spatial arrangement of hydrogen atom attached to other carbon atom called conformational isomer. If there is a large number produced, all the numbers of arrangement, and that is called conformational isomers. Then what happened here? Two types of conformation takes place. One is eclipsed one, when the rotation takes place. Sometimes hydrogen comes to near to other carbon, or sometimes they are far away from the other carbon. And about that, here two types of conformation possible, because it is observed in some rotation so many structures are formed which are hydrogen are close to other carbon, or hydrogen of one carbon and other hydrogen of other carbon, they come to close, and sometimes they are far away. Then what happens? What is the name then? One is eclipse conformation. What is eclipse conformation? Here the hydrogen atoms attach tetrahedrally, sp3 hybridization that gives tetrahedral structure. So tetrahedrally to one carbon atom completely. Hydrogen atoms attached to one carbon in tetra structure. Hydrogen atom close together as possible. So now the hydrogen atom of two carbon, they come together close, and that is called eclipse conformation. And what happened here? The hydrogens of one carbon are directly, how it will close? Then hydrogen atoms directly behind those of, see, the hydrogen atoms, if they are close to each other, then what happened? Behind those of the hydrogen atoms of other. That means you will observe this is a space arrangement, not in a copy, not on a copy or not on a blackboard. You think yourself, all are in spatial arrangement. Arrangement takes place in space. Then how can you feel they are close to each other if one is behind the other hydrogen atom of other carbon? So, or you can say the hydrogen of one carbon atoms are eclipsing. Eclipsing means close the hydrogen atoms of other. How can you feel close when one is behind the other? Then come to staggered conformation. Staggered means far away. Hydrogens are far apart possible. How they are? Hydrogen atoms are present as far away as possible. The hydrogen atoms, then how can you feel the hydrogen atoms in a space? The hydrogen atoms of the two carbon lie far apart from one another. That means you can feel, you can observe the atoms of hydrogen, they are far apart from each other, that is staggered. With respect to, staggered means far away, respect to one another. If any intermediate conformation is called, suppose in rotation, and it is, you can observe when the hydrogens are far away, that is staggered form, okay. But if between two rotation, if any intermediate conformation takes place, that means if the conformation takes place here, the conformation takes place as intermediate step, and that is called skew conformation. That means one is main eclipse form, other one is staggered form. In staggered form, the hydrogen atoms are far away from each other, and in intermediate form, that is skew information. The bond angles and the bond lengths remain the same. The bond angle remains same because it is a very, very small change. The bond angles and bond length remain the same. I hope it is clear what is eclipse form, what is staggered form, and how eclipse and staggered form takes place, and what happened about the physical and chemical properties you will see here. And thanks for watching my video. Hope you will subscribe my channel